Let us now find the volume of a pyramid frustum. Now, what does that actually look like? So what we have here is a square base of a pyramid, and we have also a square height of this pyramid. Okay, and so we connect it. And the idea here is it's not a traditional pyramid because it's actually cut off. Okay, so we would know the height and sort of the side of these squares. So maybe this one is side A, length A, and this one has side length B, and it has a given height. Okay, so we have some height to the actual pyramid that goes down to the base. And we want to figure out the volume. Okay, so the volume here is going to be some integral, and we're going to sum up a bunch of areas, right? And in this case, it's going to be a bunch of squares. And we're stacking the squares up, right? They're going to have a bunch of like dy's for the thickness. Okay, and a square clearly has area s squared, but they vary from A to B, so we need to figure out sort of, what? We need to figure out a good coordinate system so that we can get an equation to give us the square based on wherever it is. So if we take like an arbitrary square, right, let's do one that's a little closer to the top, we're going to end up with something that looks like this. And we need to figure out that. So let's put on here a coordinate system, and we're going to use, so we're going to make this kind of in connection with the lengths of the sides. So here would be like our x-axis, and then our y will just match our height. Okay, so not meant to be any curves here. We're just using this to kind of show that it's helpful to match it up kind of with the square, not easy to draw the physical thing and make it look like what it is. Okay, so we're going from 0 to h. And what we need now is the equation of this line. Okay, so what is the equation of this line? What we have here is we have 2 points on the line, this one and this one. And each time we check out the square, right, it's going to have a side that is in connection with that. Now, what is the length? What are the coordinates of this point? So the x value for this point, and for coordinates, let's use marker, are going to be x is what? Well, if the side of the square is a, the idea is, in effect, we're sort of like taking it through the middle, okay, not quite drawn to scale. And this is actually going to be, x will be half of a, and then y will be 0. Okay, that's this point. Now the second point here is going to have coordinates what? Well, the x value now will be 1/2 of b, and the height will be h. Okay, so again, we're just setting up an xy coordinate. If you want to look at it front on, I mean, it's going to be like, you know what? There's our x and y. That's the square. Okay, that has length a, so this is like 1/2 a, going from here to here. Okay, that's what it looks like head on. And up at the top here, we have like a b, right? So the whole thing is side b, and so this is like 1/2 b. Okay, and we're figuring out the line connecting these two. Okay, that's this white one here. So how do we get the equation of this line? Well, we've got 2 points. And we can use our equation of the line. So we've got m equals y minus y over x minus x. So y minus y is h, and x minus x is going to be 1/2 b minus a. Now when I write the equation of the line, I can use either point. Makes sense to use one where there's a 0. So my equation of the line will be y minus y1, that's y minus 0, equals m. And the m here is h 1/2 b minus a, x minus 1/2 a. Okay, almost there. But like, so if we plugged, so first of all, y. Y is what in connection with what we're looking for? We want the side of the square. The side of the square is not a y, it's an x, okay? So for us, okay, the way you can look at it in terms of this is the area is x squared, right? But we need it actually in terms of y. The issue is that we don't have x by itself to be able to square it. We actually need to get x by itself, okay? And that's going to put everything else in terms of y, okay? Because it's just the side, okay? It's actually 2x, right? Because if you look at it a little more carefully, because we're splitting it down the middle, the side of the square, you've got to double it. Why? Because what we're getting here is, this is our x value, okay? But you got to double that to get the side of the square. So we've got to double x, that's the side of the square, okay? That's what we need. But to do that, we got to get x by itself regardless. So if we come here and we get x by itself, that's like multiplying by the reciprocal. Now h over 1/2 is the same as 2h, right? I think that's going to make that a little bit easier. And so we're going to get multiplied by the reciprocal of this to get x minus 1/2a by itself. And you get what? You get b minus a, okay, all over 2h, because the 2 actually is with the h, times y. Okay, we just multiply by the reciprocal and then adding 1/2a. And that's what x equals. Okay, so what we can do now, we can double this and square it to get the volume, right? So the volume is equal to, from 0 to h, doubling x squared. And now is when we make the substitution to put it all in terms of y. So how do we do that? So we just got to send this all over, but note that when we put it all inside, the 2's are going to cancel with the 2 in the numerator is going to cancel with these 2's in the denominator. So the denominator is going to go away. So we get volume equals integral from h to 0. Now, what do I end up with? I've got b minus a over h y plus a over 2 is just a, okay? And that's all going to be squared dy. Okay, so that's sort of like the goal, the first goal. It's sort of having an integral that you can actually compute, okay? This is not an easy one, right? It's a challenging one. Now, when we're doing the integral here, we have a choice, right? And the choice is, do we want to multiply this out? I don't. You know, or do we want to try to use the chain rule? I think I prefer the chain rule here. And so what we would do is we would say, okay, u equals, what do we want u to be here? I think we want it to be everything in the parentheses. So we want u to be b minus a h y plus a, and then what's du? Du is just b minus a over h dy. Right? Now we're putting this into the parentheses. We don't have this, and so we're going to need to pull it out. Okay? So when we make our change of variable here, okay, so we're saying what u is, right? Okay. We're plugging in for basic, it's tricky when you have, yeah, it's y. Okay, so we're substituting in for y. So when y is 0, u is a. And when y is h, u is b. Right, do you see that? Because if you plug in h, just cancel b minus a plus a is just b. Okay, so that's switching to u. And then you've got this u squared, right? du. But then you've got this other piece. And so dy equals the reciprocal of that, you know. And so what you need to do, I might run out of a little room, is you need to actually just multiply by the reciprocal to cancel it out. And so I'll just put that here. That's going to be u over b minus a. Wait, sorry, not u. That doesn't make any sense because this is like a constant. That's an h down there. H looks a little bit like a u. Okay, so let me rewrite that. Everything times, I'll go over this to hopefully make sure the step makes sense to you. Everything times h over b minus a. And so that just comes out. Okay, why do we have that? Because it's sort of like when you multiply by the chain rule, look, you need that to cancel it out, right? If you just took this, you multiplied straight by the chain rule, you need it to actually cancel it out. So what we want to do, we need that little constant. It's just like if it was 3. If there's 3 dy, you got to put the 1/3 du. Okay, that's just multiplying by the reciprocal. So that comes out in front. Okay, so the volume equals, I've got the h over b minus a, and now the integral now is straightforward. It's just u cubed over 3, right? So it's u cubed over 3, evaluated at b and a. Now what do we get? Okay, so I've got the h over b minus a, and then I've got, in effect, I've got b cubed over 3. It's b cubed, look, it's b cubed minus a cubed all over 3. Okay? So this could be simplified a little further because this is a difference of cubes, okay? And the difference of cubes actually has a factorization. And so what we're going to end up with here, we're going to have the 1/3 h. And then one of the b minus a's is going to factor with that b minus a. You can pull out a b minus a, and what are you left with? Okay? If you're factoring out b minus a, so what we're doing here, we're factoring b cubed minus a cubed. And we're saying, hey, that's b minus a times what? Well, to make it work, you just say, okay, b squared has to give me the b cubed. But if you have a b squared, you've got a b squared negative ab squared, right? The only way you can cancel that out is if you get a plus ab squared, which you have here, and then the final term, sorry about that, the plus ab, and then the final term needs to be the, it's got to be a plus a squared to get your last term. And so you end up with b squared plus ab plus a squared. Now, let's check this using some base cases, okay? What if b and a are equal? Okay, if b and a are equal, what do we get? We get b squared plus b, we get 3b squared, the 3's would cancel, we would get b squared times h. Okay, definitely that's good because b squared times h, right, if a and b are equal, or it's a squared times h, is simply the volume of a rectangular prism with base a, say, and height b. Okay, and what if b is 0? If b is 0, these two terms cancel and you get a squared h times 1/3. Well, what's that? That is the volume of a traditional pyramid. And so this does appear to be correct. We're checking it with some base cases. Okay, a little bit of a complicated problem. Hopefully you guys understand what I was trying to do with the visual here is it's hard to draw straight on. Straight on, it just looks like that. And then I try to make it a little bit of this at the side so you can see it a little better. If you can do that one, you're in great shape for volumes. I would say that's a tough one. And just remember, whenever you're trying to do a volume of a shape, if you're not provided a coordinate system, set one up in a place where it's going to be as convenient as can. And then, generally speaking, you're going to have to connect the shape to the coordinate system, which might entail some getting equations of lines or equations of circles, and you've got to pull from your algebra to be able to do that. But in combination, using the coordinate systems with the shapes, you can get any volume.